Today we're going to cover 4 of the analysis tools, and then next video, we're going to do the final 4. These analysis tools aren't something that are hard to describe, but they're also not something that I find tremendously useful in our profession. The first one is the mesh query, and to be honest, I'm not sure when you would want to use this unless you want to get a really cool screenshot of the of your model, because doesn't that look cool? Kind of makes it very rainbow colored. I don't know why you would need this. What it's doing is it is taking the bounding box, which we've discussed in other videos, and it is calling one corner of it, it's like the front left corner of it, and it's measuring from that front left corner, and depending on how far away the vertex is, it's assigning a different color to it. That's why you get this gradient look. I don't know why that's important. Maybe if you're building something complex and things are all over the place, maybe it helps you know where up and down is, but I mean, you could do that by turning the grid on as well. Surface normals looks a little bit similar in that there's a nice little gradient. The thing that I'll show you is, if you remember that R, G, B, X, Y, Z, so R and X means that this is the X. See how these ones are red? The faces, or I should say the normals, surface normals that are facing the X direction are going to be red, and then those that are facing the Z direction are going to be blue, and those facing the Y are going to be green. And then you see, like, in between red and blue where it's like purple, it's kind of facing right in between the two. So that's what that's showing you. Again, I don't know how useful that is. Aspect ratio has to do with the size of the triangles. And also I want to point out to you that when you're in this view, you are always able to click on a triangle. And notice when it clicks on the triangle, you get all this information. I didn't know this about Mesh Mixer, but apparently every triangle has an ID number, and all of them have a different ID. If you have assigned face groups get ID numbers. But the aspect ratio is this right here. I'm guessing if you had a perfectly equilateral triangle, it would have an aspect ratio of 1. These ones are not too far off from 1, but if you look at the ones that have some color to them, you can see that that one has an aspect ratio of closer to 2. Okay, so this helps you find triangles that are at strange aspect ratios. I just don't know why, because it doesn't give you the option to fix it. It just gives you the option to find it. So I'm not sure the point of that. And then this gives the minimum angle and the maximum angle within that triangle. So with one of these that's more equilateral, you can see that they're getting close to 60. I think complete equilateral triangle is 60, 60, 60. And so that gives you the angle inside. Nearest point, to be honest, I'm not sure what that's talking about. And I don't know what a lot of these are. They're just kind of information that might apply more from an analytical point of view, but not anything practical, clinical. Going right along, internal angle, again, I don't fully understand, as all my research, both looking at mesh mixers, looking at some other videos out there, and the same with these ones. They're showing curvature. You can see right here where it's curving from one angle to another, and the same thing with the mean curvature is doing a similar thing. I just don't know why that's important. And so that's the mesh query. I don't know if you'll ever use that. The one right here, thickness, is more useful, but typically with the kinds of printers we're using, we're fine with thin spots. SLA printers do fairly well. Notice that these areas that it's painting red are areas with a minimum thickness of 1. And if you drag that up, you can see that it grows that area. The defect size is talking about how big this is right here. So if you have one area that's very, very thin, and you're not concerned about it, you can change the minimum defect size to something much larger, and then those ones won't show. Again, this is not fixing anything, it's just showing it to you. And these next options you have to change are telling it how it's finding those minimum thicknesses. The idea here is that if you were to come and zoom in on one of these triangles, I'm going to turn on my wireframe. Let's look at this triangle right here in the center, okay? If you look at that triangle, as we've talked about, every triangle has an imaginary line perpendicular to the surface called the normal of the triangle. And think of that as like if that was going straight through to the other side, think of that as 0. And so what it's doing is off of that 0, it's shooting out rays at different angles randomly and measuring how far before it hits something on the other side. And so that, you know, this one triangle here is coming straight through, but it's also coming at these different angles. And you can change those angles by changing the cone angle. Right now it's 10. Okay, so that's allowing random angles between 0 and 10 to shoot out. If you increase this, you're going to likely end up with a much larger area because now those angles are going out further. A smaller area, well, I guess some larger, some smaller areas, because now it's measuring in different angles. So if you increase the stretch, you might hit thicker areas that weren't there before, but also might hit thinner areas. So if you look right here, this picked up this small area, and if we take that minimum and bring it up, see how that falls off. So it's now not considered a defect. One thing that I'll point out is if you click on one of these, notice how it jumps out of the tool and it makes that area that you had selected. That is useful now if you want to go in and fix the area, you know what you need to fix. You could always hit Control G and add a face group to it, and then you can come through with your sculpting tool, maybe the draw, increase the size of that a little bit, and then come through here and thicken it out some. But then you'd have to go back into the analysis tool, go back into thickness, and check again. Okay, and let's see, let's bring that cone angle back down to 10. Here, we'll just type in 10 right here. So notice that the whole ear isn't red anymore, but there's still some thin areas. But notice there's a lot of these different areas. Another thing you can do to mark all of these areas is check this box right here that says Bake Colors on Exit. And you hit Done. Doesn't look like anything happened. The reason is the color mode that I'm in. If I hold down the space bar, I'm in this color mode right here. If I switch over to this one that is showing the vertex colors, now I see that all of those colors are put on, and I can go in and now I can work on thickening those areas. Now, we don't really worry too much in our profession and with the printers that we're used to using about thinness, but if we're talking, if you need to check for something that's very, very thin, then gives you kind of an idea on how you can do that. Moving right along, the strength one, what this is doing is it's looking at your whole model and it's looking for areas that are getting kind of thin and where a weak point might be. And if you click right there, you can even see, it'll tell you in what direction you're worrying about that piece flexing. So if you were to take your finger and push onto this part of the ear in this direction, there would be the most likely chance of flexure right there. That, again, you know, I did bring in, let me hit done, or sorry, let me hit this first, show sections. You can see that it's showing these different areas of cross section. In this particular object, you can see most of the flexures happening in the same direction because you have a long, skinny object. I'm going to go ahead, and I thought, well, maybe it would be more practical to bring in something like this, like a surgical guide, because maybe you're wondering where the thin areas are, and I even intentionally raised this up over the inferior alveolar nerve to make a thinner area. and then I went through and hit the strength. The problem is there's no way to tell the software what you want to call too weak. Okay, so I wanted to be able to have it show me that this is weak, but really it just shows me all of this is thinner than these areas in the back and these areas right here that are thicker. And so I'm not really convinced that that's given me much in terms of strength. I'm going to go back to our rabbit here, and I'm actually going to swap back over into this mode. And then the last one I want to talk to you about is pretty quick. Oops, analysis. It's this one called stability. Okay, what stability does is it takes the volume of your object and it finds the center point. So you can see this green sphere here in the center, how it's the center of this and it's the center of that. That's what it's, and the center in this direction. So it's calling that the center of mass. Okay, and then you look down here at the bottom, the little footprint that the rabbit has. You can see it kind of takes the outer edge of everything, and it's calling that the base. So if you take the center of mass and you put the base, if you have the center of mass in the center of the base, it's going to stand nice and stable on your countertop. But let's say you come through and you change that, and so take our plane cut, and let's say we go through like this, okay, and we accept, and then we go into the align, and I'm going to just turn on my grid. Okay, and we are going to create a surface scribble, and we're going to scribble it right there. Okay, accept. So now let's say we have a model like this, and we go into that same stability tool. Notice how we have our center of mass is right there, and here is where our platform is, and the center of mass is outside that area. And so that gives us the sense that if we had an object that we're planning to stand upright, it will not. Now, some of that is kind of common sense. This right here, this contact tool, I don't know if it's going to do much with this particular model. I'm going to undo a couple steps back to where we have our head back, hit cancel, and if I were to take this object and flip it around like so, okay, and then run the tool, stability, and you can see where this contact is. I know that as you drag this up, it does increase that size. I'm not sure why that's useful, to be honest, but that's what it's doing, is it's decreasing or increasing the contact size. And so that's the idea between these tools. So Mesh Query is helping you to analyze every triangle and to look specifically at triangles with certain information that I don't know you'll need. Thickness was a way to find thin areas, mark them so that you can go into a different tool to fix it. Strength was showing you where on your model does it thin out. And then stability, hold on, let me go back to strength. I want to try something. I didn't try this before, but if we went through, and I'm going to just select these and run a plane cut that goes right through them both. Essentially what I'm trying to do is remove anything that is very thin. And then I'm going to go into the strength one. I'm just curious. Okay, so if there's nothing that gets really thin and then big again, it just doesn't really show it, you know. So, and then the stability had to do with being able to put something stable on, like it stands on its own. So hopefully that gives you a better idea on what the tools do. If any of you comes up with a good use of that tool in dentistry, let me know.